Hello everyone, welcome to Vinoth tutorials. In this video, we are going to learn about inverse of a matrix. This is one of the most important topic in the matrix algebra. Before starting this particular topic, you have to make sure all the previous videos topics are completed, because then only this inverse of matrix will be easier to understand. How inverse of matrix is represented? The inverse of matrix is represented with a power minus 1, and this particular inverse of matrix can be solved in two ways. The first method by using the minus, cofactors and adjoint, and the second method using the elementary row operation, which is also called Gauss-Jordan method. We will see one by one. The first method is using minus, cofactors and adjoint. So in order to find the A inverse, we have to follow 5 steps. The first step is we have to verify the given matrix is non-singular. Non-singular means the determinant of the matrix is not equal to 0. And the second step is we have to calculate the matrix minus. From the matrix minus, the third step will be we have to form the cofactor matrix. Then fourth step we have to find the adjoint, and the last step is the value needs to be multiplied by 1 by determinant. The formula for A inverse is 1 by, this is determinant of A into adjoint of A. So let's solve an example. A inverse can be found, or A inverse can be solved only for non-singular matrix. That is the first thing we must know it. When you find a determinant and that value is equal to 0 means that we say it as singular matrix. And if that particular value of a determinant is not equal to 0 means then we call it as non-singular matrix. The first condition to solve this problem, either it's inverse or it's a linear equation or any mathematical problem, mostly first we will check whether the matrix is non-singular or not. If the determinant is not equal to 0, then only we proceed for the next step. We have to find the A inverse, that is matrix inverse. You can see A value is provided here. The matrix is 3 cross 3 matrix. First step, we have to check whether this matrix is non-singular matrix or not. For that, we have to calculate the determinant. In order to calculate the determinant, we have to consider the first row. Then you should remember this particular sign, plus, minus, plus. Based on this, we'll solve it now. Determinant of A. Determinant means the full matrix will be represented by single number. So determinant of A, the first element 1. For this particular value, we have to remove its row and column values and write the remaining values. 0, minus 1, minus 3, 2. Then sign minus 4. This is very important step. Minus needs to be properly mentioned. When you make minus 4 as a value, just removing its vertical and column rows, the remaining value will be 3 minus 1, 1, 2. That is this 4 values. After this, plus 1, the remaining value will be 3, 0, 1, minus 3. Now 2 cross 2 determinant is formed. Just write 1 into, we have to multiply product of principal diagonal minus product of the offset diagonal. So it will be like 0 into 2 minus 3 into minus 1, the first element, then minus 4, then these two multiplication, 3 into 2 minus, then 1 into minus 1 plus 1 into, like this, 3 into minus 3 and 1 into 0, 0. If you want, you can write. The next step is 1 into minus 3 minus 4 into 6 plus 1 plus 1 into minus 9, which will be equal to minus 3 minus 28 minus 9, which is equal to minus 40. So we can conclude the determinant of A value equal to minus 40. It means it's a non-singular matrix. Hence, matrix inverse is possible. This is the first mandatory step. We have to check it. In case if this value is equal to 0, then we can conclude saying that it's a singular matrix. Hence, matrix inverse is not possible. Now comes the second step, is we have to calculate the minus. Minus means, the definition says, if ith row and jth column of a matrix A are removed, the remaining submatrix is called minus, which is also represented by Mij. And another condition, it must be a square matrix. We already know square matrix means number of rows equal to number of columns, like 2 cross 2, 3 cross 3, and so on. For the given matrix, we will try to find the minus of a matrix. Two steps you have to remember. One is we have to ignore the values of the current rows and columns. This particular definition has been written in simpler way. Then calculate the determinant of the remaining value. We will calculate the minus of the matrix. So the given matrix written in the determinant form, that is 2 vertical lines. Now minor of first row first column, it means for this particular value. For this particular value, we have to ignore the values of the current row and column, that is 4 1 3 1. These needs to be ignored, and we have to calculate for the remaining value. The remaining submatrix here is 0 minus 1 minus 3 2. This one. Same way, if you consider 4, for 4, ignore the current rows and columns. This one, the remaining value we have to write 3 minus 1 1 2. So m of first row second column, the remaining value 3 minus 1 1 2. This is how we have to write the submatrix. And we know how to solve 2 cross 2 determinant. It is, so 0 into 2 0 minus 3 into minus 1, it is plus 3. So the final value minus 3. Here 3 2s are 6, minus into minus plus 1, which is equal to 7. Similarly for M13, for this particular row, the remaining matrix will be 3 0 1 minus 3, which is equivalent to 3 into minus 3, it is minus 9. Anyhow 1 into 0 going to be 0. And now for this particular value, that is m of second row first column, we have to write the remaining matrix. So when you cancel like this, the remaining value is 4 1 minus 3 2. Same way, for m of 2 2, if you consider 0, the remaining value will be 1 1 1 2. Then if you consider for minus 1, the remaining value will be 1 4 1 minus 3. 1 4 1 minus 3. Then m of third row first column, that is this particular value. When you remove its current row and column, the value will be 4 1 0 minus 1, this one. So M31 will be, then M third row second column, that is minus 3. Remaining value will be 1, 1, 3, minus 1. This value you have to write properly, if not you will get a wrong answer. 1, 1, 3, minus 1. And similarly, third row, third column, if you see for 2, the remaining value will be 1430. 1430. Double cross check once again and make sure all this particular determinant or submatrix written properly. This is the very important step. Then we will calculate 8 minus 3 equal to 11. Then 2 minus 1, 1. Then minus 3 minus 4, it is minus 7. Then this one minus 4. And here minus 1, minus 3, minus 4. And here 0 minus 4 3s are 12. So the final value is minus 12. We have found minors of each value. Once you are done with this, therefore matrix of minus equal to, we know its row and column. In that particular position we have to write down this particular number. So it will be minus 3, 7, minus 9, then 11, 1, 7, 11, 1, minus 7, then minus 4, minus 4, minus 12. It's a 3 cross 3. This is how we have to calculate the matrix of minus. We have completed two steps. One is to calculate the determinant, and second step is calculate the matrix of minus. Still we have to complete 3 more steps, and it's a long process. So rather than making a lengthy video, I will split finding the A inverse into 2 parts. That's the end of this video. Thanks for watching. Happy learning.